Hi friends, today we're going to do some more experiments with the Bernoulli Principle. To remind you, the Bernoulli Principle says a fluid or a gas flowing at a higher speed exerts a lower pressure. And the first thing I want to do is I want to demonstrate that. Now I have an apparatus here that I wanted to explain to you a little bit. We have a tube and a manometer connected to it. Now, right here, the tube gets smaller. And if Bernoulli is right, as the liquid flows through here, it has to go faster because the diameter is smaller. This should exert a lower pressure, and we should see it on our manometer. Again, our tube opens up. It's flowing slower, should exert a higher pressure, and we should see it on our manometer. So what I want to do is I want to go ahead and pass a liquid through here, and this is just water that I've colored red so you can see. I want you to keep track of the height of the column on each of these manometers. So let's give this a try. Here we go. Hopefully I won't make a big mess. So we'll pour that down in. And as we go ahead and pour, I think you can see our first manometer is higher, and our third manometer is a little bit higher, but our second manometer is lower, demonstrating that there's a lower pressure in the more narrowed or the faster moving tube. I also wanted to show you that when the fluid is not flowing, the level in each manometer is exactly the same. So when we don't have any flow across the narrowed area, the pressure across all three is equal, and the manometer height is all the same. We can use that to our advantage, and I want to show you some very simple experiments that you could do that might amaze your friends. So here I have just a funnel connected to a tube, and the first thing I wanted to do was to just take some foam pieces and put it in the funnel to show you that it's all connected. If I blow, I can blow those pieces out. But what if I take a ping pong ball, which is very, very light, and put it in here? You can bet your friends that they can't blow it out of our funnel. So let me show you. No matter how hard you blow, the ping pong ball won't come out of the funnel. Why? Because of the Bernoulli Principle. As the air passes over this narrowed area, it exerts a lower pressure on the ping pong ball and keeps it in the funnel. Let me see if I can even show that better. I've got to get a big breath. Hold on. Now I had to do that quickly because I ran out of air, but I think you saw that I turned the funnel over. Now, if I turn the funnel over without blowing in it, you can see that the ball falls out. But because of the Bernoulli Principle, the air is moving faster around the ball and pushing on it and keeping it in the funnel. So, let's pick this up again. How can you get the ball out of the funnel without touching it? Well, again, we can use the Bernoulli Principle. If I pass air over the top and it's going faster than the air over the bottom, it's a lower pressure, and I think if I do this right, I can lift the ball out of the funnel. Here we go. You guys ready? Got to get some air again. Now I think you saw that went pretty well. I blew the air over the top. The air over the top was going faster than the air underneath it. Low pressure lifted the ball right out of the funnel. Well, here's another application which maybe you've seen. It's called a wind bag. And all it is it's a plastic bag, and it has one end open and one end is tied. So, hi. So I moved back so you can see this better. Here's my bag, and what I was trying to say was, if I just put my breaths on it, it'd take hundreds of breaths to blow it up. But if I take one big breath and use the Bernoulli Principle, you can see I filled the whole bag up. Now, what happened? Well, as I blew air, that air moved faster. As it moved faster into the bag, it created a low pressure and pulled other air with it because of the low pressure, and we could easily fill our bag up with just one breath. That's all for now, and that was more fun with the Bernoulli Principle.